Now we're going to look at the same kinematic equations and being able to solve for things, just instead of it being in the x-axis, the y-axis. So we're going to go vertical here. The main thing you need to know is that the acceleration of gravity is 9.81 meters per second squared, and you choose positive and negative based upon the direction. Now, an age-old myth or story that you'll hear is that if you drop a penny off the roof of the Empire State Building 381 meters up in the air, that it would crush and kill, not really crush, but would kill the person that it hit down below like a bullet falling down on them. That's not true. We'll get into that. It's air friction is the answer. But here's where that idea comes from. Let's neglect air resistance to start out with. We have the acceleration of gravity, 9.81 meters per second squared, and I get to pick which way is positive and negative. Now, in your x-axis kinematics, it was always pretty simple. You would make the direction things were going positive and the other direction negative. Here, though, you get to choose and choose wisely. Since everything is starting up and going down, I'm going to purposefully choose down to be positive and up to be negative. And it doesn't matter which way you choose down and up, positive, negative. You just must be consistent for the entire problem. So I'm going to go down as positive. I'm going to go ahead and write down all my variables now. Two things you should be able to see in this problem, or we're looking for two things here. It says how long, that means time, and also what velocity does it hit. So we're solving for final velocity and time. Since I'm calling down to be positive, everything that goes down is positive. That means the acceleration. Acceleration of gravity always goes down towards the Earth, so it's positive. Also, look at the direction we are traveling. If I call up here 0, my initial position, y naught, so my x naught changed to y naught, my x changed to y. Not a big deal, just to represent the axis that we're on. If I call this 0 and we are going to go down 381 meters, I'm going to call down positive. If you decide to call down negative, your acceleration of gravity would have to be negative because it's going down, and your final position y would have to be negative if you're calling this 0. You could reverse that if you were calling down negative and flip-flop these two, but you can look into that later. And now I've got my variables. Let's go ahead and let's pick an equation that will allow us to solve for time. All right, now all we have to do is substitute it and solve, chug through the problem. So with significant figures, I come out with a time of 8.81 seconds, 3 significant figures here in the distance. That was the only number given. You wouldn't be told in a problem the acceleration of gravity. Notice nowhere in here did it say the acceleration of gravity is 9.81. By the way, please consider the acceleration of gravity to be exact. Even though it changes, that number will not factor into your significant figures. We're looking for how long, and nor did it say, it said the penny is dropped. That implies that it's falling, so you know acceleration of gravity. It also implies if it's dropped, the initial velocity is 0. So from only being given one variable here, you know 2 others. So only being given the final position, you also know the acceleration of gravity, and you also know the initial velocity, just simply from the idea of something being dropped. Able to solve for time. Now let's pick an equation and solve for final velocity. So according to this, whenever the penny comes all the way down and is about to hit the ground, we're going to be traveling 86.5 meters per second. If you need that in miles per hour, that's just shy of 200 miles per hour. That's fast enough to kill somebody, but that's neglecting air friction. That's in future problems we'll do. All right, this problem is something that we have all done at some point in time in our lives. We're waiting for a friend, we're at baseball, softball practice, or we're just outside for fun, and we have a ball in our hands, and we throw the ball up, and then we catch it. So the girl is outside with a softball. She throws it up in the air at 27 meters per second, and then I want to know what is the maximum height the softball reaches, neglecting air friction, and how long will it take before it comes back down for her to catch it. So she throws it up in the air 27 meters per second. How long will it take? What's the maximum height? One thing you do have to know is the velocity at the max height, if you will, is always 0. The ball, or whatever you throw up, and that is in the y-axis, whatever you throw up, whenever it reaches the max height, it's slowing down, it's decelerating all the way up to the peak. And at the peak, its velocity is nothing. because it's slowing down on the way up, and then its velocity turns around and comes back negative and comes back down and begins to accelerate back down. Velocity at the maximum height is 0. If that thought really blows your mind for some odd reason, and we're calling up positive and down negative, think about this. On the way up, the ball is going with some positive velocity up. Let's say we're right now, it's near the top, and so we're going up at 3 meters per second. But it's decelerating. Gravity's pulling it back down, so its velocity is falling down to 2, down to 1, and at the maximum height, you're at 0. And then the ball turns around and starts coming back down. It picks up speed, but it's going down, negative, -1, -2, -3. So this idea at the maximum height you have 0 velocity, think about a number line. You cannot get from positive numbers to negative numbers without moving through 0. All right, so I wrote down everything that I know trying to solve for the maximum height it gets up to. Just because the object is going up doesn't mean that it's not subject to gravity. Everything in free fall is subject to gravity, whether it's on the way up or down. Free fall includes on the way up. So as it goes up, gravity is decelerating it down. Notice I chose down to be negative and up to be positive here, meaning the initial velocity, which is going up, is positive, and the acceleration of gravity, which is always, no matter what, down towards the Earth, is negative. The final velocity, because I'm looking for y max here, that's the final position, I set the final velocity to be 0 because that's the velocity at the maximum height. So I looked at my variables and then I picked the kinematic equation that fits. And I come out with a maximum height of 37 meters with sig figs because of the 2 sig figs and the initial velocity. All right, now let's solve for time, how long it takes to get all the way back down. And to do that, I'm just going to solve for the time it takes for the ball to go up to the maximum height and then double it. Reason for that is if we neglect air friction, everything is uniform. The time it takes to go up and the time it takes to go down is the same as long as it's acting under the same acceleration, which we are under constant acceleration of gravity. It's whenever accelerations change at some point, whether it goes from a constant velocity, acceleration 0, to a constant acceleration of some number, or you just change braking gas in a car or whatever. Whenever the acceleration changes, that's whenever you have to break the problem up into separate pieces. But this is all the same acceleration, so I'm going to solve for the time it takes to go up, and then I'm going to double it. So the amount of time it would take to go all the way up is about 2.75229 seconds, somewhere in there, so 2.75 seconds. And I'm not going to round for significant figures here. In fact, please don't round for significant figures in any of your problems until you're at the very, very end in the final answer you are reporting. Now, this is the time it took to go up. Notice I set the final velocity here to be 0, the maximum height velocity. And how long it takes to go up is how long it takes to go down. So all I need to do is multiply by 2. And I come out with a total round trip time of 5.5 seconds rounded for sig figs.